All right, so now we're going to discuss how to write the absolute value as piecewise for linear function when the inside you have a negative slope to begin with. Now, this isn't in slope-intercept form because the negative is back here, but anything in front of the x is where slope would be. So this is currently a slope of -2. What that means for me is if I take this absolute value v concept and understand that part of it's got a negative slope and part of it has a positive slope, what I have inside of here is currently representing the part that's going down. So that's 4 minus 2x. What I need over here is the reflected version of that. And so what I'm going to do to make that happen is just put a negative in front of a parentheses of 4 minus 2x. Now, technically what I just made there, if I distributed, would be -4 plus 2x, which would be in slope-intercept form 2x minus 4. Notice the slope is positive. I'm going to leave it like this for the sake of this problem writing in piecewise. The idea is I'm just most concerned about when this transition happens and noting that what was given to me is already the negative version of the line. So just like the previous problems where we had positive slope, I set the inside 4 minus 2x equal to 0, and I solved for when this transition happens. The transition happens when it hits the x-axis. And the easiest way to solve is I'm not gonna move the 4, I'm gonna actually add the 2x to the other side so that I don't have to deal with dividing by a negative, which I'd prefer not to if I can avoid it. So 4 equals 2x, and then I divide both sides by 2, and x will be equal to 2 because 4 divided by 2 is 2. So the transition here happens when x equals 2. And so what that means is everything left of 2 will actually use the definition of this function that was on the inside already. So I say x less than 2 will produce and use that rule. And everything right of 2 is written as x bigger than 2 will utilize this definition. Then just one of them needs to be written as less than or equal to with the inequality symbol. So I'm going to say x, just like before, I'm going to put the positive one on top. X is greater than, and I'm going to throw in the equal to symbol there, 2, and then here's going to be x is less than 2. So because I wrote the positive one on top, this is the one that requires the negated positive slope version. So I need to make this one -4 minus 2x because technically that's 2 minus 4x, or sorry, 2x minus 4, where I have a positive slope. And then the second one was the way I was written and presented the problem, 4 minus 2x, because that has negative slope. So this part goes to the left with negative slope. This part goes to the right with positive slope, which is the case because there's a positive value out in front of the absolute value. So this is a happy face v. So we got one more example here where we have negative slope presented to us inside the absolute value. So there's a linear absolute value function. So it just looks like a v. And our job is to recognize that this is the definition for the left-hand side, left of the transition. So this is the 12 minus 3x portion of the graph. And to get the right-hand side, it's going to be the negated to get a positive slope. So -12 minus 3x portion of the graph is going to be on this side. This gives me a positive m. If I was to distribute that in there, you'd see it's positive 3x. Now, that's the concept. Now, the idea is, where's this transition? Because that transition is what I need for the rule over here. So I say 12 minus 3x equal to 0, because that'll tell me where it hits the x-axis. And so just like the previous problem, I'm going to, let's change it up. I'm going to subtract the 12 just to change my solving strategy so that we can consider dividing by a negative. We'll work it through. So -3x equals -12. And this time I have to consider what happens when I divide by a -3 to isolate. And anytime you have a negative divided by a negative, it's going to turn positive. So on the left-hand side, that turns out to be x equals 12 divided by 3 is positive 4 because the negatives cancel out there. So that said, I have a x equals 4 as my transition moment. And so I need to go left of 4 and right of 4. So left of 4, so x less than 4, I use this definition. And x right of 4, bigger than 4, uses this definition. So that's what I'm going to do over here in the pieces. And just sticking with the form that I've had, I'm going to keep the positive one, the one moving to the right up on top, x greater than 4. And then this moving to the left on the bottom, x less than. I'm going to use the equal to symbol down there just to show you it doesn't matter if you put it on the top or bottom, as long as you only use it once. And then over here with my definitions, the positive slope one is going to be the one with the negative sign out in front of the parentheses, 12 minus 3x. Because if you distributed that negative sign, it would make that a positive 3 slope. It's technically the same thing. I could have written 3x minus 12 here, but we'll just leave it without, you don't have to distribute. So 12 minus 3x is my version with the negative slope, and that's the one I use with that rule moving to the left. So this is how we break up absolute value functions into its component pieces and set up the rule.